Hello, my lovelies, it's Susanna, and today I want to show you how to solve this problem. The areas of the individual rectangles are given in the drawing. We can see this here. For example, the area of this rectangle is 24, of this one 42, and so on. Can you calculate the area of the red marked rectangle? Okay, so we want to find the area of this rectangle here. Maybe we start somewhere with the ones where we know the area. So let's start with the 12 one here. If we know the length of this side, I'll just call the length x for now, and the length of this side that I call y, then we know that x times y equals 12. And I would take that as a first equation. So x times y equals 12. We have two variables here, but only one equation, so we would need some more information. So maybe we go to this rectangle here then. If we take a look at this side, that is of length x as well. So they share one side. So here we have length x as well. The other side, we don't know the length of this one, so I just call it a. Okay, so that we have three variables now, but maybe we can find some connection between a, x, and y so that we don't have too many unknowns here. I would prefer just to work with x and y, so maybe we can get rid of a. As an equation, we know that a times x equals 24. So a times x equals 24. So we have a system of equations here now. We said that we want to get rid of a. I want to use both equations for that. So maybe let's solve the first equation for x. And after we've done that, we're going to insert it then for x here into the second equation. So first of all, we take the first equation. It's x times y equals 12, and let's solve this for x. We just have to get rid of the y here, so let's divide both sides of the equation by y so that this cancels out and only x is left, and on the other side I have the result of 12 over y. This is my x. I'm going to insert it now into the second equation here for my x. So in the second equation, I have a times, instead of my x, I'm going to write 12 over y, and on the other side, I have the 24. Let's solve this for a now. We have to get rid of this fraction here. We can do that by multiplying both sides of the equation by its reciprocal. So we are going to multiply it by a fraction. We take the y and write it on top, here and here, and the 12 and write it down here and here. Like this. This y cancels out, the 12 cancels out, and only the a is left. And on the other side, if we multiply here and make the calculation of 24 over 12, which equals 2, we have 2 times y as a result for our a. So instead of a, we can write 2y. And if we compare the lengths of these two sides now, we have length y here and 2y here. So the length of this side is twice the length of this side. Could we have seen this way faster than doing all these calculations here? Yes, we could have, because if we take a look at the areas, we see that this area here is twice as large as this area here. And because these two rectangles share this one side here of length x, then the other sides have to make sure that this ratio here of the areas is going to be correct. So if this area is twice as large as this one, then the length of this side here has to be twice the length of this side. So we can use it from now on, not to do these calculations anymore, but to compare rectangles and to see if they have sides that they share. So for example, this rectangle here and this rectangle here, they share this side here. We don't know how long the side is, but we know they have the same length, and if we take a look at the areas, we can see that this area here is half of this area. And the length of this side here is y, so the length of this side here has to be half of the length of this side, so 1/2y. Okay, so with these here, we now know the length of the height of our red rectangle here, because we only have to add these two. So we have to add 1/2y and y, so it's half of y plus 1y, which would be 1.5y if you want to use decimal numbers, or I prefer fractions actually, so I would write it as 3/2y here for the length of this side. And with this, we can also say how long this side here is, because the entire side is 2y plus 1y, so 3y. And if this part here is 1.5y, we said, now I go back to the decimals because it's easier to get to 3y then in total. If I have 1.5y here, I am going to have 1.5y here as well to get my 3y in total. I don't want to mix these two, so I stay with my fractions, with my 3/2. You can tell me in the comments which you prefer, decimal numbers or fractions. I usually take the fractions. Okay, so what do we see here now? These values are the same, which means that the length of this side here, so I'm going to draw it here, the length of this side is the same as the length of this side. And if we compare this side here, this has the same length as this side down here. So we can now compare this 42 rectangle to these three rectangles together. Because this green length is the same and this orange length is the same, the areas of these rectangles have to be the same. So this 42 rectangle has to have the same area as these three rectangles together. Let's call the area of this red rectangle that we're looking for A. And if I add these three areas, so I have A plus 9 plus 18, and this has to be 42. So let's solve for A. 9 plus 18 equals 27. So if I want to solve for A, I just have to subtract 27 on both sides of the equation so that I have my A here. This cancels out, and on the other side, 42 minus 27 equals 15, and this is the area we were looking for. If you like this video, please give it a thumbs up. It helps me a lot. I wish you a wonderful day, and I hope to see you in one of my next videos. Take care.